Hello and good afternoon to all of you. I hope all of you are doing well and all of you in good health. In today's class, we will discuss priority scheduling and round robin scheduling. To begin with, let us try to understand priority scheduling. So, priority scheduling is a scheduling technique wherein a priority value is associated with each and every process. Again, I'll repeat it. A priority value is associated with each and every process, and the CPU is allotted to the process with the highest priority. So a process among all the processes that has the highest priority will be assigned the CPU first. In situation if there are jobs with equal priority or equal processes with equal priority, then FCFS scheduling algorithm is used for selection of the process for allotment of CPU. So here it's a very simple scheduling algorithm wherein a priority is associated with each and every process, and CPU allotment is done as per the priority. So the process that has the highest priority will be allotted the CPU first, and in situation if there are jobs with equal priority, so FCFS is used in order to schedule the processes. Now, let us try to understand priority scheduling with the help of an example. So here I have 5 processes A, B, C, D and E with the CPU time or the burst time, and then we have the priority. So priority assigned are 5, 4, 3, 2 and 1. So here let us consider that lower value of priority means a higher priority. So lower the priority value, higher is the priority. So here now what I have done is I have sorted the jobs as per the priority of the processes. So E has the highest priority compared to that of D, then C, then B, then A. So here what I have done is I have sorted the job list or the process list based on the priority value. So now what we'll do is we'll schedule the processes or allot CPU to the processes. So here there are 5 processes starting at 0th instance of time A, B, C, D and E. So since E is the job that has the highest priority, so E will be scheduled first and E will execute till 7. So once E finishes at 7, the next highest priority job is D. So D will start at 7 and it will go till 12. Likewise, D will finish at 12 and then C will start. So C will start at 12 and it will finish at 15. Likewise, B will start at 15 and finish at 19, and eventually A will start at 19 and finish at 25. So this is a schedule created of the execution of the processes based on priority value that is assigned to the processes. So based on priority value, the process list is sorted, and then the CPU is assigned to the various processes. So here, so since E has the highest priority, so E will be executed first. So start time is 0 and turnaround time is exit time. So exit time is 7, so 7 minus 0 is 7. For D, so turnaround time, so exit time is 12 and arrival time is 0, so 12 minus 0 is 12. Likewise for C, exit time is 15, so 15 minus 0 is 15. For B, exit time is 19, so 19 minus 0 is 19. Likewise for A, exit time is 25, so 25 minus 0 is 25. So here the average turnaround time is 15.6. Likewise waiting time, so waiting time is turnaround time minus burst time. So 7 minus 0 is 7, 7 minus 7 is 0. Likewise for D, 12 minus 5 is 7. Likewise for C, 15 minus 3 is 12. Likewise for B, 19 minus 4 is 15. Likewise for E, 25 minus 6 is 19. So here the average waiting time comes to around 10.6. So this is the way how the turnaround time and the waiting time is estimated. Likewise the average turnaround time and the average waiting time is estimated. So this is a very simple algorithm. It is very easy to understand and it's very easy to implement. Here, since priority is associated with each and every process in the process list, so what we need to do is we need to select the job with the highest priority and then schedule the jobs as per the priority that is associated with the respective jobs. So it is very easy to understand and very easy to implement. So it's simple to understand and easy to implement. scheduling algorithm, and here it creates a kind of favor towards a high priority process. So in situation when higher priority process comes in, so it may create a situation of starvation where low priority process may be executed very late in the execution cycle of the CPU. So this is the way how priority scheduling algorithm works. Now let us move on to round robin scheduling algorithm. Now round robin scheduling algorithm is a scheduling algorithm wherein the CPU is allotted to the process in a fair basis or on a fair basis, wherein a process executes for a given instance of time. So that instance of time is called as a quantum. So every process executes or is allotted CPU for a quantum unit of time, and it will release the CPU once its quantum is over, and then it will wait for the next allotment of CPU to the process. So that is the way how round robin scheduling algorithm works. So round robin scheduler employs time sharing, giving each job a time slice called the quantum. So round robin scheduler employs time sharing. So here different processes that are there in the process queue or the ready queue will share the CPU time among them, wherein each job is given certain amount of time, that is called as quantum. So each process gets a chance to reschedule after a particular time. So this is well understood. Each process gets a chance to reschedule after a particular time. Now quantum or time slice is used to switch between the processes. This is implicitly understood. So quantum or time slice is used in order to switch between the processes. Now it is similar to FCFS scheduling, where preemption condition to switch between processes. So it is similar to FCFS scheduling with preemption condition to switch between processes, where preemption is done based on the quantum value. So this is in brief what round robin scheduling algorithm is. So round robin scheduling algorithm employs time sharing among various processes that are there in the process list, where each process is given certain time slice, that's called as quantum. So each process gets a chance to reschedule after a particular point in time. So quantum or time slice is used in order to switch between the various processes. So let us try to understand it with the help of an example. So here I've taken the same 5 processes A, B, C, D and E, and in the order A, B, C, D and E with a quantum value as 2. Right? So there are 5 processes A, B, C, D and E arriving in the sequence A, B, C, D and E with the quantum value 2. So now here we'll start with the execution. So A, B, C, D and E starts at 0th instance of time. So first A will be given the CPU for 2 units of time. So A will execute from 0 to 2. From 2 to 4 B will execute. From 4 to 6 C will execute. From 6 to 8 D will execute, and from 8 to 10 E will execute. So this is the way how round robin algorithm basically works. So it will execute a process for a quantum unit of time, and then it will carry on with the other processes that are there in the process list. So it's quite a fair algorithm. So 0 to A will execute from 0 to 2, then from 2 to 4 B will execute, from 4 to 6 C will execute, from 6 to 8 D will execute, and from 8 to 10 E will execute. Now likewise, after E completes its execution, then the process repeats. So again A is allotted CPU, so A will continue from 10 to 12. From 12 to 14 B will continue. So at 14 instance of time B gets over, or B is completed. Now likewise 14 to 15 C is allotted, but C requires only 1 unit of time. So from C will execute from 14 to 15 and C completes by 15. So from 15 to 17 D gets its chance and D executes, and from 17 to 19 E executes. Now likewise from 19 to 21 A executes, and A finishes its execution at 21. Now from 21 to 22 D executes, because D is left with only 1 unit of execution. So from 21 to 22 D executes, and D terminates at 22. Now likewise from 22 to 24 E executes, and from 24 to 25 E again executes. So this is the way how the execution is done with the help of round robin scheduling algorithm. So here we'll estimate the turnaround time and the waiting time for the individual jobs. So for A, so turnaround time will be, so A completes its execution by 21. So 21 minus 0 is 21. For B completes its execution by 14. So 14 minus 0 is 14. C completes its execution by 15. So 15 minus 0 is 15. D completes its execution by 22. So 22 minus 0 is 22. E completes its execution by 25. So 25 minus 0 is 25. So the average turnaround time is 19.4. Now likewise waiting time. So turnaround time minus burst time. So 21 minus 6 is 15. 14 minus 4 is 10. 15 minus 3 is 12. 22 minus 5 is 17. And 25 minus 7 is 18. So average waiting time is around 14.4. So this is the way how round robin scheduling algorithm works. Now some of the advantage of round robin algorithm is that it's a very fair algorithm wherein every process gets the share of CPU after a certain interval of time. Disadvantage, it has a larger waiting time and response time. It has very low throughput. It has frequent context switching, and it's a time consuming scheduling in situation if the quantum value is very small. So this is all about priority scheduling and round robin scheduling. So this brings us to the end of the process management chapter, where you have learned about processes in greater detail, and eventually we have discussed various scheduling algorithm with its description, example, and advantages and disadvantages. So thank you very much. Have a very good day.